Hi everybody, myself Dr. R. Balamurugan, working as an associate professor in the Department of EEE, K.S. Rangasamy College of Technology, and I'm going to explain about AC to AC converters. So let's see what is AC to AC converters. So basically, what is AC to AC converters? So the converters which converts either voltage fixed into variable, we call it as AC voltage controllers. Suppose if the same AC voltage with the constant voltage as a varied frequency at the output means we can call it as a cycloconverters. So these are the outline of this AC to AC converters module. So here we are going to see about the AC to AC voltage controllers, thyristor cycloconverters, matrix converters, and the other AC to AC controllers which is come under the AC voltage controllers. So let's we go to the topics. So this is the single phase AC voltage controller. You can see here. So it shows the voltage waveform and with the circuit which controls the output. Here these are the, you can see the pointer here. These are the two switches which is connected in anti-parallel, which is connected with the load. Here we take SCR AC voltage controller. So what's the best example we can say means we can have a control over single phase AC voltage controller. For example, we can use it for motor control, single phase motor control. So here two SCRs are connected in anti-parallel. One SCR will give the positive of output and another SCR will give the negative of output with respect to the connected supply, right? So here when the supply is given positive of means T1 will be conducted and the output will be given as like this. Suppose if negative of is given as the input means this negative of output will be coming. So both will be having the same firing angle. So this is the working of a single phase AC voltage controller, and we can have, if it is a resistive load means output of the output will be like this voltage. This is will be output voltage. This waveform shows the output current. Both will be in phase, right? So we can have explanation over 0 to pi, then pi to 2 pi. So let's we go to the next controller. So these are the some of the equations which is derived for resistive load, and you can see the RMS output voltage, RMS value of output current, and power factor of the circuit. Here I am connecting the RL load. Simply load will be connected, so we can observe the continuous and discontinuous waveforms in the output waveforms. So this is the quantitative analysis for an inductive load. So these are the types of AC voltage controllers. You can go with the three phase. So here it is a Y connection, it is a line controlled delta connection, it is a branch controlled delta connection, it is a neutral controlled delta connection. You can have a look over these diagrams. It can be explains about the three phase AC voltage controller which can be applied for industries. So this is the three phase 3-wire Y connection, that is star connection AC voltage controllers. So you can see the devices, which is, suppose if it is a three phase means we should connect 6 number of SCRs. It should be connected with anti-parallel directions. So for a phase we have to connect with two switches, and another phase we have to connect with two switches, and another phase we have to connect with two switches. So each phase has thyristor conducting for respective positive of and negative of, and there are two thyristors conducting for each phase, and the load voltages of the two conducting phases are off of the corresponding line to line voltage. So let's we go with the control of this AC voltage controller. So integral cycle control. So here you can see the control over this AC voltage controller, that is single phase. We can have integral cycles controls. So what is integral cycles controls means? So for a certain period of cycles we can have an integral cycles control. So after that we can leave the control, then we will give some certain cycles the phase control. So this type of control we call it as an integral cycle controls. We have to calculate the number of cycles which should be controlled, that can be controlled with respect to the gate. So the spectrum of current in the AC power controller. You can see the spectrum. This is the harmonic spectrum which can be observed in this AC voltage controller. So next, electronic AC switch. What is electronic AC switch? Like fan regulator, ceiling fan regulator, we can use this electronic AC switch, which is nothing but a anti-parallelly connected SCRs. So you can see here. So this is nothing but electronic AC switch, because for positive of one side resistor will be connecting, for negative of the other resistors will be connecting. So suppose if it is in 3-phase means we have to connect with 3 different types of that is 6 number of switches, the 3 different types of connections. All will be showing anti-parallel connected SCRs. Next, these this is the next circuit with connection with the capacitor. You can see the output waveforms also, which is used as an electronic switch. Here we are using this as an electronic switch with respect to the diode. Here you can see 2 switches are thyristors, and here you can see one switch is a thyristor, one switch will be a diode. So here thyristor will controls the output. This is an uncontrolled device. So we can say it as an working operation of this AC to AC voltage controller as AC chopper. So this is one of the circuit configuration which shows the output voltage controlled with respect to the applications. Single phase thyristor cycloconverter. So next thing we are going to say about the fixed frequency with constant voltage to variable frequency with constant voltage. So here, suppose if an application needs variable output, variable frequency output, we have to connect with this cycloconverters. You can see the circuit diagram which is shown here. This is positive group and this is negative group. One will be acting this direction and another will be acting this directions. So what it does means we can have types of cycloconverters also. So in that we can see if it can be a single phase cycloconverter or 3-phase cycloconverter or single phase to 3-phase or 3-phase to single phase. So you can see the single phase cycloconverter here and the output which is shown here. So this is the 3-phase output and this is a template for the output. So you can see the single phase thyristor cycloconverter here. Typical waveforms. This is a template of, suppose if it is a 3-phase to single phase means we can get the output like this. 3-phase to single phase cycloconverter means we can get the output like this. This is a template with the output which follows this template. So this is the control methods which is used for calculating the delay angle for the cycloconverter. This is the output voltage ratio which is obtained for the cycloconverter for different control values. So this is 3-phase cycloconverter. You can see the output diagram, and we can have a more number of connections like 3-phase to single phase to 3-phase based on the applications. That's all about the cycloconverter. Thank you.